drink with your maple syrup?
It was Jack Daniels.
Tennessee sipping whiskey. Oklahoma, Tennessee.
They call it Tennessee tea. Edit that out.
Note to self.
Nothing to do with whiskey. All right, so Module 9, Application Security. Doing good here. A little bit left to go. So that looks all very, very complicated, so pay no attention to the man behind the curtain. We're basically going to talk about programming, all the things that wrap around that, including data. Well, some of the easier stuff is the database management process, database code, malicious code. It's going to be some low-hanging fruit, things like that. Nice, easy points in here. All right, so we can sum up this whole thing by saying that programs are written to function, not to be secure. So you have some choices here. You could design them to be secure in the first place, using good programming skills, or you can retrofit them with firewalls and access control lists and everything else, front-end controls, back-end controls, like that. But it'd be cheaper to design it securely in the first place. So you got to understand the objectives of the software, what the goals are of the developer, what's the application doing basically. So you could design it securely, or you can just put layers of defense in there. Firewalls, IDSs, you could scan for vulnerabilities and mitigate those. But layers work pretty well. That's your defense in-depth theory right there. So you want to ultimately reduce the attack surface. And you can do that by patching your systems, keeping them up to date, latest and greatest. Use antivirus software. Properly configure the software. In other words, no default usernames and passwords or default settings. Or design them to be secure in the first place. Remember, you have people problems, process problems, and technology problems. So make sure your technology is configured and up to date, and latest and greatest. Make sure you have a process like change control, so you can control the software, and train the people too. So most systems today follow one of the two basic designs. You either have centralized or decentralized. Decentralized is a little bit more common, but difficult to secure because of the decentralized or distributed factor. Centralized is easier to secure because everything's in one location. So issues with the centralized model. Generally, application is housed on a dedicated system, such as a mainframe or a terminal. It's considered more secure because there's, the attack surface is on one location. So it'd be like one set of firewalls versus, 15 sets of firewalls. But it may require expensive or proprietary hardware and software to actually get it to work. Like, have you heard of the Siemens hack? The Siemens, or like in Iran, they use Siemens equipment.
Oh, Stuxnet?
Yeah.
Stuxnet? Yeah.
Yeah, then they, I forget the exact nature of the detail, but it's...
There's lots of them.
Yeah, they basically had the Iranians, flipping out and going in circles. But it was an advanced persistent threat that was on that system and caused chaos.
So it's really spread across all the systems almost.
Yeah, you can have attacks that are things that attack certain applications, services, or hardware, and if you don't know what you're looking for, you'd be scratching your head trying to figure out why the stuff's not working. So some issues with the client-server model. There's multiple clients, multiple points of contact, and nowadays our clients are going distributed wirelessly and mobile. Everybody's got laptops in here. I noticed this week nobody bothered to bring a desktop computer and set up a monitor and all that other stuff.
Yeah,
it's probably a good thing. Plus, you got multiple types of operating systems, right? You got Mac. Everybody wants to use their Mac or their iPad, and they want to integrate that with their Windows or their Linux machine. So when you have multiple types of applications, it's not standardized, which is a higher cost. Remember in one of the first case studies we did, we talked about standardizing basically. Mm-hmm. All right. So issues with the client-server model. You can add an agent for what feels like everything nowadays. But every agent you add to a machine, if they're all doing something different, you can really slow down a machine. You look in the bottom right-hand corner of the Windows desktop, and you see all those things in your task tray. All that stuff slows down your system. Applets are a good example of agents too, and they can come in the form of like ActiveX controls that will, run in your web browser and grab things from your hard drive. Or Java applets, those are typically the cooler applets. They do really, really cool things to stimulate your web browsing experience.
How is that utilized to penetrate the system? How is it compromised?
Like an ActiveX control.
Sure.
Let's say you have an with ActiveX, that's client-side scripting, if you will. Same thing with Java, it runs on the client. So from across the internet, you could write an ActiveX control or a Java applet to basically do things on the client system. And if you know that type of operating system, which Java applets are platform dependent, you could have it do things like read your cookies, copy files, change the display of your mouse. I mean, just to name a few. And so you have to watch for, does that application delete its tracks or attempt to look at your temporary internet files to load in other ads or something like that. So you got to watch out for, if you're reading cookies, that would be an attack on privacy or confidentiality. If you're deleting things from the hard drive, that may be, an attack on integrity. Just to give you an example. But nonetheless, all of these are running on the client side. So there's vulnerabilities.
These are source code based type attacks, or meaning that they manipulate.
Well, you'd have to watch the source code, which brings us up to the ActiveX signed applets. So basically, it's a digital certificate with the applet that says, "Hey, you can authenticate this applet and prove that it came from, for example, Microsoft." As opposed to Leo writing an applet and putting it on Leo's web server, and I would do things like read your cookie files or maybe search your contact address book or something like that. Well, not that I would, but a hacker would. All right. So you got types of applets. You got Java and ActiveX, and security is handled differently for each type of these things. ActiveX, pretty much since Microsoft invented it, it can do just about anything to the system, where Java uses this thing called a sandbox. So you keep your sand in the sandbox for unsigned or untrusted applets. And then you are running it on the client machine, so that can be a problem. So you got environmental controls. These are global configurations affecting hardware, services, or anything in between the subject and the object. You can get as granular as you want in terms of access controls. So you can have controls on the operating system itself, or the application on the operating system, or even to the databases you connect to. I would say layers of this is probably appropriate. Make sense? You guys with me? Say uh-huh.
Uh-huh.
All right. So finding the appropriate level of security is not always easy. You have to balance this. So it's functionality versus security. More functional environments usually translate into less secure one, and more secure environments translate into less functional ones. So it's functionality over security, numerator, denominator. As your denominator increases, security increases, the numerator functionality would decrease. So you should properly write your applications. This helps ensure the appropriate security and functionality. So for example, fields in a database could have limits on them, like a username field. Does anybody have a username of 500 characters? Could you probably say that 99% of all usernames are 16 characters or less on average?
Yeah.
Well, in that case, 16 characters or no more than 20 would be a good, good starting point. Also, the lack of input checking, right? Like when you register on the website, any website, what can you put into that field so that when you click submit, what happens to the server? Can you put a SQL shutdown command in a form and hit submit, that go to the server interpret that command and go, oh, I must need to shut down, and actually shut down the server. Things like that happen when you don't have input checking. Circle input checking. All right. Commercial software can get installed with defaults, which could result in an insecure state. In theory, everybody wants to make user-friendly experiences, but by making it extremely functional, you also can introduce security vulnerabilities. Printers are historically known for this. Excuse me. For example, you get a printer, take it out of the box, plug it in. It's got AppleTalk installed, IPX, SPX, TCP/IP, and it's broadcasting out to the network. Hey, I'm a printer. You guys can connect to me. You know, print. It attempts to be functional, but it's not exactly hardened. If you're not using Apple, you need to remove the protocol. If you're not using IPX, SPX, you need to remove those protocols. You know, disable things like printing of reports and things like that. Watch out for overconfident administrators. When we were all in our isolated networks, this really wasn't much of a problem, but now that we're all interconnected, you got to watch out for this type of problem. You should always have a default to no access. We've talked about that. You know, starting in a closed state and then adding exceptions versus starting in an open state and then trying to harden the system. So, implementation issues can fall into a couple categories. Unnecessary services should increase the attack surface. Some services you can't do much with. Instant messaging is known to be extremely insecure, or let's just say extremely functional, and therefore hard to keep secure. Because you can send somebody a malicious href or HTML link, and they just click on it. You know, you can spoof identities and things like that. Plus, it might be outside of the scope of your security policy, so you're going to have problems enforcing it. So it's really easy to say, you know, no unauthorized software, for example. Agree or disagree?
Agree.
All right. So application development needs to consider a response of the application to a failure state. What does that mean? Two words are
You don't accidentally nuke Russia.
Well, we're in response to a failure state, a buffer overflow. Right?
well.
Is that one of the
We're
things?
getting to resume in a
Outlook.
safe. That's the emphasis right there.
Outlook closes abnormally, you can choose to open it.
Fail what?
Fail safe.
Fail safe.
Fails
Or
out.
fail secure.
All right.
So like if you have a bank vault, you want that to fail secure. In other words, fail to a locked state. So that way, you know, one strategy to rob the bank would be just to pull the power cord of the bank, and you know, if the bank vault opens, that would be no good. So you'd have it fail to a secure state. The exact opposite of that would be fail to a safe state, like a fire exit. You know, the power goes in the building, or the alarm system fire detectors go off. You'd want your emergency exits to fail to a safe state, or in other words, you can open the doors.
Right.
Which is why you have fire code saying, you know, don't pile things in front of the doors, don't put deadbolts or chains or anything else on those types of doors. Because in the event of emergency, they need to fail open.
Unless you're on a Navy ship, which they all fail closed.
Depends on the environment. Right. So databases are going to play a key role here. This is where we're going to keep our stuff.
Acceptable loss.
Might hurt somebody's feelings with that one.
You can contain it to a,
I've lost enough buddies.
Fair enough.
Maybe on the couch.
So a database is data that is stored in some sort of useful way. The database management system is basically everything else surrounding the database. And then, of course, you're going to have a database administrator who would perform your admin functions. But, some common databases, you got Oracle, you got DB2, Sybase, you could have, FoxPro, SQL Server.
Fox.
Ooh, DBase.
Fox Road.
I haven't heard that name for a while.
Still a database. Just antiquated. Well, think about it. Well, why does that matter? If I find an old database that doesn't have security controls in it, and I can get into that, database and actually search for the administrative account and pull the MD5 hash, and it's the same admin password that they're using on the other systems because it's antiquated and they still got to manage it, I'm a winner. As a hacker, I win. You know? So you look for the lowest hanging fruit. In many cases, that means old fruit.
Old stuff.
Old fruit is low fruit. Old fruit falls from trees first. So again, you don't want to beat your head against the wall. I'm not going to try to break into your network by breaking AES encryption. I promise you I'm not going to do it. I don't have 72 quadrillion years to hang out until the results come back. You know, but if I can find one old antiquated database that you just can't get rid of, jump for joy, because that's probably the one I'm getting into, you know, as an attacker. All right, so would you like some easy points?
Of course.
Basic terminology 101 here. We already know the subject and the object, and then the software is the middleman in between the subject and the object. So software like Open Database Connectivity, ODBC, for example. But a record is just a collection of related data items. These are flashcards here. A file, collection of records of the same type. Database, cross-reference collection of files or tables. You got a tuple, that's an easy one, a row. An attribute is a column. I don't know who came up with the database terminology. Personally, I'd like to go wring his neck or her neck, or whoever it is. Because why couldn't you just call it a row?
Yeah.
What's with the tuple? Why are you doing that to me? You know, hope they do. So now you know. But a primary key, that is a very important
Kind of like a nibble.
thingy.
Kind
Or
of
a
like
bit.
You know what a nibble is?
I forget, but you got nibbles, you got bits, you got bytes.
You'll have to bite.
Is it half a byte? And there's another one too. You got nibble. What's a really big one? And there are nibble, a bit, nibbles and bits, nibbles and bits. Because that was a joke with nibbles and
Nibble is
bits.
half a bit, half a bite, 8 bits.
Yeah, but there's another one. You got nibbles, you got bits, you got bytes, and there's also
A bit, half a bit.
Another one.
Half a bit.
Anyway,
Yeah, you're right.
what's a primary key?
4 bits.
Nibble, yeah. Nibble is half a byte.
Half a byte.
bit.
Nibble is half a byte.
Okay.
Because a
Which
byte
would
is
be
4
bits.
bits.
Or a byte is 8 bits. And nibble is 4 bits.
4 bits. Okay.
Yeah, how could you have half of a bit?
You can't have half a bit because it's
Right.
1 bit.
Right, it's either on or off, 1 or 0, and what do you get, 0.5 out of that? You know, it's not possible. Does that have to be a byte?
Go watch Tron.
Watch Trump.
Remember bit?
Yeah.
And so the secrets get revealed. What's a primary key?
Oh, sorry.
That's the unique.
Right, it makes the records unique. What's a foreign key for 100 points?
The references a unique key from another
Beautifully said.
File.
A foreign
Table.
key is a primary key in another table.
That's
It's a referenced key in another table. So it keeps the integrity of your data. So you can't have duplicate records. Primary key, that's worth 1 practice test question. All right, so there's 3 types of databases. Would you like some super easy points?
Of course.
All right, you got relational, you got hierarchical, and you've got distributed. So relational, here's the obvious stuff. It's just referenceable tables. Hierarchical, like DNS is an example. It's a parent-child or trunk, branch, leaf models. And distributed, that just means, multiple locations. And so let's hit them. Whoops. All right, I thought they were coming up. All right, so let's prove these while we're at it. So, like, for example, can anybody give me an example of a hierarchical database other than DNS?
Excel.
Well, you'd have to build hierarchy into Excel. Excel's pretty
Yeah.
static. How about XL500?
Yes, that would be our criminal database.
All right, how about LDAP databases?
What's your problem?
Or any directory service?
That
Or
would make
less.
sense.
Or distributed. Here's an example of distributed. You ever go to Barnes & Noble and say, do you have this book in stock? And they say, oh, we don't have it in this location, but we have it in one of our sister organizations, sister companies, whatever.
We haven't sent it to you.
Yeah, we have it sent to you, right? So what they've done is they searched the logical database, which was one, but physically in another location. As you can manage, backups are going to be much more difficult in a distributed environment because you have to go to each location and perform the backup basically locally. Or you can do it remotely, you just need bandwidth. Auto parts stores do that. You get an auto parts store chain, like Advanced Auto Parts, and they say, no, we don't have it in this store, we have it in another store. They're using a distributed database model because they tell you where the part is in another physical. Anytime that the physical location differs, you can search it. When you get differences in physical location, that's distributed. Relational is common for stores, maybe like inventory systems, or you want to relate all your products. You have different product tables.
Well, stores are, a lot of the chain stores now have the distributed databases so that they can look up other locations.
Could you have a hierarchical distributed database?
Sure.
Why not? Right. Could you have a relational distributed database?
Sure.
Why not? Right? So in either hierarchical or relational, you could have multiple locations.
Yep.
That's the moral of the story. All right. Database management systems. If the data is in the database management system is everything else wrapped around it. So a couple terms here. You got data definition language. This is the structure and the schema of the database. I use the word design for schema. Schema is really a design. So you have to define the data. What's it going to look like? What are your constraints? What are your primary keys? So you have to define the data in the database. Then you have a data manipulation language. This is how you're going to get into the database, make changes, or retrieve information from a database. You got query languages. Anybody want to guess an obvious one?
Queries.
Structured query language or MySQL. Right? And of course, you'd always want to have reports. Today we got reports for reports. Make sense? Questions? Sure? All right. So what's a data dictionary? You ever heard of metadata?
Yep.
It's data about data. So if the index of a book is data, that data would be data about the rest of the book, which is also data. So metadata is often data about data, or the index of a book is data about the rest of the book. So in many cases, do you want to read the whole book to find out if you want to read the book? No. In many cases, you might just want to search the data dictionary, find out if it's got, or search the index, find out if it's got what you want, or if it's of interest to you, rather than reading the whole book or searching the whole database. So, essential database of the data elements and their relationship. So it defines the types of subjects and objects, access control methods, what tables are available, any constraints, all that would be in your data dictionary. How many views, how many tables, it's a nice summary. Would you like some easy points? You gotta know aggregation and inference. Aggregation, in parentheses next to that, that means collect or combine. Parentheses next to inference means assume. So let's collect a bunch of information and start making assumptions on it. That's aggregation and inference. Now databases in many cases can be tricky, but remember our context versus our content. Where you put the control matters. If you put the control in the front end, like in Access, and you restrict who can even query to the database, that's a context-based access control. If you have a firewall in between the subject and the object, that would be context-based access control. Versus if you restrict the database view or do something like polyinstantiation on a database table, that would be a content-based access control. So don't forget those. So you can control access through access control list or views. It all depends on where you place the control in terms of content versus context. So security in a database system can happen in many ways. You can use access control lists. I can define role-based access control. Like, for example, only human resources can query the payroll field or your salary field. but a user could only access their own record. We know what a capability table is, right? In a capability table, what defines the capability? Is that the row or the column?
The road.
The row. The capability is the row in a table. We could add labels to things like in mandatory access control, or we could do view-based controls. I mean, this is like basically a whole college semester on DBMS, if you will, in about an hour and a half. So any questions, please just let me know. So aggregation. Hey, look at the key word there. Combining or collecting. So the user may have the ability to access data in separate parts, construct the parts together, and then assume a trend or a pattern. Hence the inference. Which really brings us to data mining and data warehousing. Data warehousing is collecting of multiple databases or log files or whatever you're collecting, data. And then your data mining is really your inference. You're trying to find new trends and patterns. So data mining could be used with, quote, combining, unquote, to gain access to sensitive information. You may be the, synergy, right? What does synergy mean? Sum is greater than the parts. So 2 plus 2 equals 5. So if you collect all of the databases, could you potentially get access to something of higher sensitivity? You may not be able to get something top secret, but if I can collect a bunch of secret stuff, I could infer that something top secret's going on. Possibly. In theory, anyway. Question?
Classification by aggregation.
Yeah. And we'll talk about the countermeasures of those too. Questions, anyone? Ben? You good? And then inference, right? The user deducts information or assumes. The database view, abstraction of the data that controls the level and amount of information from a single or group of tables. Basically, what is the user's interface to the data? For example, in college, I wrote a ski shop application, and I had the checkout counter. They had their view of checking, basically buying stuff, a purchase view. But I also had an inventory view, and then, different views for different, to make different reports out of, which was a relational database, but not limited to. This is the view of the information. What do you want on any one view? Would you like some super easy points? You gotta know what polyinstantiation is. So how do you eat an elephant?
One bite at a time.
So what does poly mean?
Many.
What does instantiation mean?
Put into place.
Instances.
Instances. It's a big fancy word for instances. So many instances. This is many instances of classification. So, for example, I could use this on a warship. Does the person fueling the ship need to know what cargo is on the ship?
No.
No, so let's give them a secret clearance. They got to have a secret clearance just to, put fuel on the ship. But all they really need to know is how many gallons or liters. Do you think the captain of the ship needs to know the cargo of the ship?
Yes.
Because there's nuclear weapons. The fuel boy, he doesn't need to know. But the captain needs to know that there's nuclear weapons. So when the fuel boy goes and searches the database, he gets basically, hey, there's fruit on board. When the captain searches the database, he goes, oh, there's nuclear weapons on board. So you can have different or many instances of a classification, depending on who needs to view the data. It's used to prevent inference or aggregation. Let's do data.
Back up, please.
Whoa, back up. What do you got?
That second bullet makes no sense.
I multiple sets of
You're
data.
saying I'm gonna put in complete dummy data? Is that what it's trying?
You can, to countermeasure the aggregation and inference attack, you could insert white noise.
The way I read that is, you're saying that these are either instances of or definitions of polyinstantiation.
Okay, yes, you could have bogus data. The fuel boy could know that there's fruit on the warship. It's humanitarian aid. The cargo's fruit. So yes, you're essentially lying. Bogus data.
Okay.
I mean, for the purpose of, if in some cases, just even knowing what the data is, just saying, hey, you can't have access to that. So if the fuel guy, if he searches the database and it just says, you don't have access to that. Well, that in alone could say, something's going on here. So it's a tip off to, hey, there's top secret stuff going on here and you don't know. So, he could call up his buddy and say, you know what? I've fueled many ships before, but I've never had an access denied. Something's going on here. This could be the moment you've been waiting for. I'd follow the ship, track the ship. So you allow them to search the database. You just give them dummy information. Yeah, there's nothing on the ship. This isn't the nuclear cargo. There's just fruit on it. Don't follow the ship. See the difference? So it's basically white noise or bogus noise or false data. So you're purposefully dumbing down the data for the sake of, and you know what? You can see people like the press secretary. You see them stumble over their words all the time because they have to really watch what they say and how they say it to not disclose, potentially something of a higher sensitivity level. In some cases, they'll say, you can't ask that question. That in itself is saying, hey, there's really something going on here, and I just can't talk about it. I can't disclose it. Agree or disagree? Everybody on the same page? All right. So you got data mining. Third of the way down. You got data mining. This is analyzing data for the purpose of looking for trends and patterns. For example, in a galaxy far, far away, I once worked in a place called Company X, and we took all of their log files, firewall logs, intrusion detection logs, and server logs, and this log and that log, and a couple more logs after that, and we collected them and we combined them into one location. Basically, now that alone would be just duplicating the data, which is of really no value. So then you got to do something called normalize that data, which really means remove all the duplicates and just get it down to the core data. That is the scenario that I just spoke to is basically a data warehouse. Well, because I collected all the log files, I could data mine for new trends and patterns. Cross-reference all of the log files and the timestamps. Time is now critical to have accurate time because you got 1,000 log-ons per minute sometimes between 8 o'clock and 9 o'clock in the morning, and if your time is off by a second or even a minute, the difference in records between similar events could be pages and pages and pages off. So it's critical you have synchronized time in this stuff. So you need an NTP server somewhere. But data mining, what I'm doing by looking at those logs files, I'm looking for trends and patterns to discover things that I wouldn't have been able to see if I would have just searched one database by itself. Because I'm correlating or cross-referencing all of the trends and patterns. That's knowledge discovery. So you can do it by classification, you could do it by statistics, the simple number of events, or maybe even if it was probabilistic. What's the probability of something happening? So in this case, let's pretend that tool is called ArcSight. ArcSight is a data warehousing and data mining tool. And you can do things like watch viruses spread in real time. It's pretty cool stuff. Watch it trip IDS logs and server logs and host logs and host IDS logs and network IDS logs and correlate that traffic and build a visual map of what's happening in real time. Pretty powerful stuff. So with developing software, there's really a couple key areas you need to pay attention to. So who's going to be doing the security management during this? Hopefully it's not the same people managing the database. You have database administrators, and then you should have security administrators. Also, you can build life cycle into this. Everything from initiating to decommissioning or lessons learned. That's why we have change control or integrity control, because you can manage each part of the life cycle separately and get that through change control. So, security needs to be included during the development process. You should draw up your security plan. Do a risk analysis. So here's your life cycle. Pretty much like a project management life cycle. Looks familiar. You do your project initiation, functional design, analysis, and planning. During that time, you can do things like risk analysis. And you can design your system specs and start doing control measuring. Then eventually you end up writing some software. And this is what bugs me about college classes, because you go into a college class day one, they just start having your program right away. And they forget, oh, by the way, you'll never do that in the real world, because you have to plan this stuff. It's a whole life cycle process. And newly college grads tend to miss that until they've been at work for a couple of years and realize, you just go open up your command prompt day one and start typing. All right? So once you actually develop the software, you're going to have to install it, test it, validate it, get it through change control, and then actually get it into a formal production environment. Then maintain it throughout the rest of the life cycle as long as you're using it, patching it, updated, service packs, all that other fun stuff. And then, this may be hard to believe, but one day you'll actually take it out of production. So it does not become a legacy system or an antiquated system. So you got stage one, project initiation. This is where the concept's born. This is where you identify all the features, all the benefits. Circle risk assessment. During process initiation, you do your risk assessment. Notice security is now being involved right from the beginning, in theory, in this pristine world of ours. Which normally happens where, right? Where's security brought in the big picture, as is right now?
Operating.
Yeah, when they want to finally put it, in place, then they, call security. By the way, we need your certification and accreditation, so go ahead and do this. And at that point, it's like way too late. It's like, sorry, the train's already left, buddy. And now, all of a sudden, an emergency on your behalf does not constitute an emergency on mine. You should have brought me in and gave me the proper time to do what I needed to do. So risk assessment, risk management, qualitative, quantitative analysis, that's all done in project initiation. Everybody agree with that?
Yes.
You gotta get that. Because we're doing risk management, we want to identify threats and weaknesses right from the beginning. Thank you. Stage two, functional design and analysis.
Snag this root beer. Just one.
So steal my root beer on Wednesday. Functional design, right? When you're designing this stuff, this is where you start designing what security checks you need to put in place. So what checkpoints? What integrity checks or confidentiality checks? Or let's add in polyinstantiation. Let's add in white noise or bogus noise. Let's start building a baseline. And by the way, where do you start documentation? Yeah, not here, okay? Here. That way when you get to the installation and change control, you already got your documentation. You just need to compile it and submit it. But if you have to go back and try to collect all that stuff from all the people you should have been collecting it from while you're running it, now you got a documentation hole. All right? So document from the document from the beginning all the way through. Not just, oh, by the way. That's another, you can always tell newbies by how well they document. If you've been around for a while, you're used to documenting everything.
That was a big problem.
Yeah, how big of a problem?
We used to have people who would bring the products to be evaluated. We had to send them back to them because they didn't document all of the process procedures or any of the information involved in that particular product. So it's to go back,
Right.
and then come back.
Yeah. That's also where the term undocumented feature comes from. I forgot to document that one.
Yeah, see, they present you with a product.
AKA whole.
Yeah, they present you with a
AKA
product.
bug.
It's their product. They don't provide you any information to help you if there's a failure, how to recover from it, that type of thing.
Right, the operational stuff.
Yeah.
They give you some procedures, but the procedures are isolated and autonomous and, informative, but you don't always get the big picture in that too. And think about it from this point of view. You have technical writers and you have security folks. Very rarely do you have a security technical writer. The personality or the role or responsibility is, we want it now, we want technical writers for security. That person doesn't exist though. So you have to find a technical writer that likes security stuff, or a security person that has the ability to technically write. But go try to find a security technical writer. I mean, don't hold your breath on that one. All right, also your formal baseline is created. You need to know what is in each stage of this. So test questions for our practice test would be things like, during which stage of the system development process is a functional baseline created? And you need to know, A, B, C, or D. Also, quality assurance. Start doing that now under functional design. System design's a phase. This is also stage 3. How information will be processed. You got the informational stuff, how you're going to process the information, but also how you're going to actually get it to work. What's the functional application here? Or how's it going to behave during the key states? So what's the concept of state? What's the state machine concept? From Tuesday or Wednesday?
That it always maintains the three CI triad.
Right. The state of integrity, the state of confidentiality, the state of availability. And you maintain state during system startup, operation, and shutdown. So it's predictable. You want to predict how the system's going to behave. That gives you trust or assurance. That's why they don't call us information security, because nothing can be 100% secure, but it's information assurance. Assurance is a measurement of trust. So how do you trust the systems will behave? We provide that trust level. Software development phase. This is where programmers actually begin writing the code. So they should write their code securely to try to put limits on fields to prevent buffer overflows. Or you have different groups of people. Split role. What is it? Split something. I forget. What is it? Remind me. Split role. Split separation of what?
Separation of duties.
That's it. Separation of duties. Couldn't remember. So how does separation of duties play into this?
For your testers, the testing's not done by the programmers.
Right.
Nor do you want the
People writing the code aren't the people testing the code. And if you've ever written any sort of paper for school, you can read that thing 50 times and you think, it's perfectly written. As soon as you give it to somebody else, it's like, you spelled this wrong, you spelled that wrong, you spelled this wrong, you spelled that wrong. And you're just like, man, I read it 500 times. How's it possible? Your eyes get used to it. It just becomes white noise after a while. Right. Then you got your installation process, right? You got to get it from the testing and validation environment actually into production. So you got configuration issues. You may have to go through your certification and accreditation. I should be certification then accreditation in my opinion. Certification means what?
that you validate that it meets the security requirements.
Well,
The testing of the
Testing.
security.